So now what we're doing is 17C. Explain how the size of the sample standard deviation influences the likelihood of finding a significant mean difference. So what I've written up here, 17A, we had the standard deviation of 4, an estimated standard error of 1, right? Because the n didn't change between these two. So if we increase the standard deviation from 4 to 12, that meant that our estimated standard error increased from 1 to 3. Increasing the estimated standard error decreased the t. The t critical, that depends on your degrees of freedom. Your degrees of freedom depends on the number of scores you have. That didn't change. It depends on 1 or 2 tail tests. That didn't change. And it depends on your alpha level. That didn't change. So our t critical for both of these was plus or minus 2.131. That didn't change. But what did change was the t. And the t went from being reject in the critical region to not. Initially, so we have negative 2.131, positive 2.131, right? So initially, the value we calculated was out here, it was 3. That was for 17A, right? So 17A, we calculated a t, and it was out in that critical region, and we rejected the null hypothesis. When, I'm going to have to erase this part. When the standard deviation of the difference scores increased, our estimated standard error increased, our t decreased, and our t for 17B, our t was 1. So it went from being in this critical region, one of the critical regions, to not. If your estimated, if your standard deviation of your difference scores increases, then your estimated standard error increases. If your estimated standard error, let me write this out. So if your standard deviation increases, then your estimated standard error increases. If your estimated standard error increases, your t is going to decrease. And in terms of the likelihood of rejecting the null hypothesis, likelihood of rejecting your null is going to decrease. It won't necessarily flip from being statistically significant to not statistically significant, but it's going to flip, or it's going to decrease. Okay, so now what I'm going to do, that's the end of this question, but what I'm going to do is I'm going to go back to the values for 17A, and I'm going to calculate Cohen's d, I'm going to calculate r squared, and I'm going to do a confidence interval.